So as I was saying, as we can see, first of all, that this is the Ricci tensor, the Ricci scalar, sorry, multiplied with the square root of this minus g. I call it Ricci scalar density. I have this to be equal to f plus that. F, of course, is what we've obtained to be this whole thing. So I can have it to be written out this whole thing here, plus this 2 here, and plus this one. So I've just simply opened up the brackets here. So multiply this first time with square root of minus g, and the second with the square root of minus g. That is what I have there. Okay, so one thing that I've tried to make an identification of here is you can see that this term here and this term are sort of similar. That is, if I should simply just change beta here to gamma. If I simply just change beta here to gamma, they are the same, of course, except for the signs and the factor of 2 here. So this is going to subtract that. Now on these two terms again, I'm suspecting such kind of combination 2 for the 2. So because of that, I'm making some interchanges between alpha here and gamma. So I'm making an interchange here between, alpha and mu. That's what I'm going to do here, alpha and mu. I'm going to make an interchange between alpha and mu. And here I'm going to make an interchange between alpha and beta. All these are possible because alpha, alpha, beta, beta, as you can see, alpha, alpha again, and mu, mu. All these are dummy indices. Okay, so let's do that up here. Well, as I was saying, the 2 books I've mentioned are all very good books, except of course that I've seen in those books tensor expressions or equations in which you have on the term an index repeated more than twice. So like I've said, these are very good books, except for that particular caveat. And I have to warn you, so you have to be very careful whatever you see in those 2 books. Okay, so next, as we were saying, this is r square root of minus g. This is g mu nu, gamma, alpha. This is mu nu, square root here of minus g mu. Okay, I'm not making any interchange on this one, so we can just write it out the way it appears here. Square root of minus g, and all this is comma alpha. Now on this term here, I have some plus 2 gamma alpha. I don't need to do that, all right, because it will be just being redundant. I've already said that if I made this interchange, as you can see, if beta changed to gamma on this term, it's just the same as that one. You can look at it again carefully and confirm that that is true. So I'll simply write 1 of that. I don't need to repeat myself. So those 2 combine by 1 subtracting the other. And I have here gamma alpha nu. And this is g mu nu here with the square root of minus g. So we're done with these 2 terms. Now these ones are the ones we wanted to take a few more steps further to see how we can combine them. So this is minus 2, and I'm making the interchange between alpha and mu. So this becomes alpha, for instance, gamma alpha, and then here I have gamma, and I'm changing, this is nu and this is mu. This becomes g mu and nu, and all of this is multiplied with the square root of minus g. And I have here with me plus g mu nu, and then here gamma alpha, I have mu nu. So we said we're going to make an interchange between alpha and beta. So this is no longer alpha. So the first step we're making is making alpha, so this becomes beta. And then I have here with me gamma, beta alpha, and this is alpha times the square root of minus g. Yes, that's it. Now one other thing we intend to do is to change beta to gamma. If we were to do that, I think these 2 terms become equal because as again, except for the signs and the factor of 2, I have mu nu here. Beta becomes gamma, just like I have gamma here is a dummy index. I have, of course, the alpha, and this is alpha. Square root of minus g mu nu. So finally, this looks like I think we're home, and I can erase these expressions down here. Okay. With that said, we have here again G mu nu gamma alpha mu nu square root of minus G mu alpha gamma nu mu nu, and then square root of minus G comma alpha. So I have simply plus here gamma, this, and then that here gamma alpha nu G mu nu square root of minus G, and then of course this should be simply minus alpha gamma alpha gamma nu mu G mu nu square root here of minus G. Okay, and that is that. So of course the next and very simple thing that we will have to do is to substitute this back into our original expression for the action. The integral then is given by I sub g to be equal to c cubed all over 16 pi g, the integral here of r, that okay. So all we have to do is to substitute this for that in this expression. Let me start with the second one. I think the second one I can write as c cubed all over 16 pi g. The second one, for no just particular reason, I decide to pick that first. I can put g mu nu, which is common to all of them. Gamma alpha mu gamma alpha alpha nu minus alpha gamma gamma mu, and then of course they are both multiplied with the square root of minus g, and all this as we can see, as it should be. Okay, no, we can't say it's multiplied, but because remember everything we obtain is the expression for that, right? So avoid the confusion of saying multiplied again by square root of minus g. Minus g has already been infiltrated in our expression right from the onset, so this is what we have. Then I'm going to have plus. Like I said, I wanted to avoid writing the first one first. So I'm going to have c cubed here, 16 pi g. Then I have the integral. Okay, nothing particularly. So I have here g mu nu alpha mu nu square root here of minus g mu alpha gamma nu mu nu square root here of minus g, and this is comma alpha, and I've got that. Okay, so the second integral or second term in this is you can see I have a partial with respect to x alpha. It's completely covariant, and I can write this by Gauss theorem. It's one thing that we have always done particularly. So anytime you have such an object, let's just say some tensor. Let me do that. And alpha integral of d4 x. Usually, of course, because we write from the beginning, we added the square root of minus g. But just to let you see what I mean, I can write this as that, and then it becomes the s. I'm integrating this now over the surface s. So by that theorem, Gauss theorem, which we have stated and used over and over again in this series, we're just going to make the same exploitation here of that theorem. Of course, we can write this again in terms of a surface integral instead of a full volume integral. And then performing the integration over all space, which is what we always say, this integral then vanishes. So this second one here is 0. So what we're left with is this. In other words, we have been able to show, well, I don't know where else to do that, but I think maybe we should just take a look here to avoid being redundant. This is g mu nu out here, and this is square root of minus g. What have we got in the bracket? I have here gamma, alpha, gamma, this is mu, and then here I have gamma, alpha, nu. Of course, I can make an interchange on this particular term between alpha and, what is it called? Alpha and gamma, yeah. If I made that interchange between alpha and gamma, then my nu will be with gamma here, as you can see. This becomes gamma, and this here becomes alpha, just like I have it here. right? And then it will simply mean again an interchange between. So the one with the one here that is should be with alpha mu, then ends up having a gamma on top. So we have just simply confirmed. Just take a careful look at this. I don't think it's too much of a problem. Just take a look at it and you'll be able to confirm that it's true. This first time has been confirmed. So now let's move on to the next one. Again, here we are seeing a dummy index. Alpha, okay, that is repeated with gamma. So this was particularly exact, as you can see here. We did not make any more transformations. Then the one with gamma has mu. Well, it doesn't make any difference because this is just mu. So indeed, we have been able to show that this expression, or this integral written out originally as this, is just equal to that. This again, as you can see, had to do with the exploitation and application of the Christoffel symbol or affine connection all through right from the beginning up to this point. Well, hopefully we'll be able to drive more results and then be able to solve a more wholesome or a holistic problem. With all these results, I'm sure when that time comes, we wouldn't need to do much. Thank you again for taking this ride with me. Hopefully we meet again in our next presentation.